back. This is a little follow-up to the conversation about how memory works, variables, arrays, typed arrays. It was kind of a question that came up in one of the forum threads. So I wrote a visualizer. Well, I turned the example I wrote and I added a visualize function to it, or functions to it. Let's just run the example. Hit F5. So this is showing the internal table of variables that I've had to give them names. So I've added some extra functionality to it to do this. But it'll show you an array, shows the address in memory of this cell, as well as the syntax you would use to access each cell. In this version here, you can actually you can enter data into it, so you can change them. The second one is what's interesting about this demo is I've used the typed array. I'm updating the typed array like they're characters in the background. They're just bouncing balls pretty much. Well, wrapping balls I should say. And if I hover over the record of each one, it'll highlight the one I'm looking at. And if I click on the size of something on this 20, let's make it 200, I can change their size. Now it's a bit of a novelty, but it gives you an idea about what's going on. So in a typed array, we've got the buffer has this base chunk of memory. This is indexed in a linear fashion, so that each cell is one integer apart, and these are handles to types, which is what the lines here represent. These are in memory somewhere else. We don't know where they're going to be. And the fields themselves are in a linear fashion as well. So they just stack up, in other words. Each field is after each other. Now, of course, if we have things like strings inside this would be different. A string is just a handle to a string buffer. The text isn't stored within the type or within the variable or a string array. It's the same principle. But anyway, so I'll put this up on the forum for you to play around with. Maybe it'll give you some ideas about what am I changing the direction. Make 90 degrees. Change its size to 100. Let's change its Y position back to 10. That kind of thing. Maybe you can do something like this in your own programs. This is just looking at a chunk of memory and displaying it for you. The hovering stuff is just working out where the mouse is as we draw this stuff. But the code's all there for you to pick apart. Go back to it. So our display memory function is running through our variable heap. I've just added a variable name so we can have something to display what this thing is in text. Got different classifications what these things are. So if it's tagged as being a variable, it's just a normal integer. Tagged as being an array or a type array, we use a secondary function here to render that chunk. So there's more data with those things. Like a variable is just displaying the name and the value on that row, and then moving on. I'm doing some clipping here, but there's no hovering ability over those. I didn't bother. This display function here is down the bottom. We're passing it the global variable index of this thing, of the array or the typed array, which is back here if you've forgotten. This magic number here. So all variables have a unique index within the program, which is given to them at compile time. So the names we use are converted to these indexes, etc. So here I've added some extra stuff there for display purposes. I'm going through and setting the variable names, what type they are. I'm using text because it's just kind of convenient for a demonstration. I have added one extra thing here, which is the visualizer part, which is, I guess you can pick through that yourself. Go back to the draw array thing. So we're drawing the array first, and if it's a typed array, then we draw the allocated types within that space. The scrolling is just done as an offset. So we're giving it a position on screen to draw this thing, and it might have been up or below the screen. So if it's way off the screen, we just don't even bother drawing it. Well, I would hope so anyway. Did I even add that? Maybe I did, maybe I didn't. Some things are clipped, I know some things are not clipped. But anyway, so when we're drawing an array, we're running through, we're getting the handle of this array. In PB terms, it's actually a bank. We're computing the size by dividing it by 4, because an array is really just, if we have 200 cells, each cell is 4 bytes in size, and so the one integer in size. So we need to divide that value by 4 to get the number of integers in this thing. We're going, is this a typed array? If it is, we need to display a secondary thing. If it's not, we just display the information as we said. If it is a typed array, I get the fields which I've declared somewhere else, so I can, for display purposes, create the dialog panels, do a bit of extra messing around. These things stack up over time. The draw loop for the arrays is down here. We're looping through, getting the value from the array, giving it, computing the address, the array name into a string, checking if the mouse is hovering over it, and if it's on screen, we draw it. Probably should check if it's actually on screen. We're checking if it's above the frame, but not actually below the frame. So text pushed way off screen would still be drawing, still be trying to be drawn. So that's kind of a wasted opportunity there. If we are clicking the button and we are not a typed array, if we are over the cell, then we bump the change dialog, which just really just is given a pointer to this thing we want to change. In this case, it's got the true set because it needs the routine handles 2 different things. There's 2 different modes. Are we changing an array index or are we changing a type field? That's all. We read the value from the pointer, make a message, show the dialog, return. The method I'm using to draw the panels, I'll run the program again actually, so we see the type panels. So this is the array panel. So everything just has an offset, a vertical Y offset, so that when we start drawing this thing here, we're given a Y offset. Adding or subtracting to that when I scroll the mouse wheel. If you're not aware of how that works, pretty handy. It's a nice little trick. It makes programs feel much more comfortable to use. So when we display an array panel, we're drawing the cells in here. If it's typed, we store this point, this location of where the number ended, and we drop the type out to like a stack beside it, pretty much. So if this array has 100 cells, we have 100 potential stacks, and we're just slotting one in wherever we want. And what you could do is that what should happen if I don't declare one, if I declare type 14, for example, it should actually update all those other ones. This is kind of going to be awkward to do that, but we'll do it anyway. How's that sound? If I just make this a subroutine, I'll butcher this up a little bit for us. I'll put that in a sub. I just want to call this block of code that creates a type in our simulated memory, a particular index, my character, it's bad guys, isn't it? Bad guys, my character, give it the index. I better move that down the bottom there. Sorry about making a mess of this. It's pretty messy anyway. Put this down the bottom. So inside our creation loop, we can now theoretically call this to create the first 11 instances. I know this array has got 20 elements in it, so if we create one that's at 15, whoops, wasn't watching what I was doing, obviously. Run again. it's not declared within that scope. Handle is used, well, that's all we need, those variables there. Okay. So now this time we've got a new type at position 14. We can't edit those ones there, it doesn't allow us to change the handle, but down the bottom 14 should be just this position here, because they're just stacking up on for display purposes. What you could do is you could have like a little bit of code up here to open the panel and expose it. So if you wanted to make something like this for your own game, to edit the properties of characters or to look through what's inside your character arrays, that's how you might tackle it. Maybe collapse certain points or whatever, or just only display the one you click on over here, for example, which probably makes more sense actually. But for the purpose of the demo, it's there. Let's set this thing to, so that circle there is our, where are we? Make it 140 in size. Has no speed. Oh, actually, it's not being updated in the refresh loop. It's not being updated because this here has no way of knowing if something is allocated or not. We have to add more logic to that. If we're doing it like a PV way, for example, we're reading the field. We go down the bottom here. What's the type array? Read handle from here. So I can read the handle and check if something actually exists, rather than just pass through something that may or may not exist. Okay, this handle was our variable we used before. Our index is going to be position this loop variable, and our name of our index of our bad guys array is up here. So we're checking this position and we're going, does this handle, if this handle equals 0, then continue. So in other words, if it's empty, jump to the next end of this loop. Don't even, well actually we do want to draw it. No, sorry, we don't want to draw it at all. That's fine, yeah. What am I thinking? So we should be able to set this to 19. Now you've got to be cautious here because there's no clipping of these functions. The array we allocated up the front here, wherever this was in this monstrosity of code, has 20 elements in it. I haven't provided a function to read the number of elements from an array. Now I told you before, you can compute this by getting the size of the handle if it exists. But for demonstration purposes, this is not really necessary. You could do this stuff if you wanted to build your own runtime, your own compiler, and then back end to run your code, you'd have to. But this example is kind of a mini version of how programs are compiled into bytecode and how those bytecode instructions operate to recreate the program that you write. Wow. Making sense? I hope so. Let's run it one more time and we'll see if we've got our last object updating. Looks like it is. There it is over there. So that's good. It's position 15. Good. We'll give it back to 30. Should appear over there. Go up to here, 60 or something. Change color, give it a hex value, purple color, I guess. If I hover over it, it flashes. So, because before I found it, so it was difficult to work out which one you were changing. In your real project, if you're going to use this kind of idea for it, you would have some sort of highlighting mechanism. I don't know. maybe the camera can move to that position or something like that. In here, I've just kind of used a bit of a cop-out method. I did write a bit of a function that can display the fields. Where is that? Sorry, it's down here. So I give it a declaration in our program. Yet again, sorry, I'm jumping around too much. You'll have to look at this program and state, oh, there it is. So there's a visualize script here for typed arrays, and it's like calling a circle function. Now what we're doing here is the type that you provide it has to have X field, Y field, size and color. So when we go to visualize this thing, what it does is it breaks that visualization stuff up into the command name and the parameters. If it's the circle thing, I'm not sure it even checks that. I don't think it does actually. It runs through and grabs the parameters, looks for them in the type. Is there a field called X position? Is there a field called Y position? Is there a field called size? And this means that you could change the type and this would still work. If I just gave it a bunch of fixed offsets, then it would have to update the visualization script all the time with it in the future. I thought it was kind of an interesting way of doing it. Here I'm doing some validation of have we read the field correctly or not. So I'm searching for it in the type field names. If it exists, we go, okay, set the variable, and we add a mask, we add a value to say, yep, we've got that field is correct. We look for the next field, that happens to be the Y, look for the next field, happens to be the size. If they are were all found, mask could equal 15. There's a bit of a hack there to take one off these values because they're offset by one in some earlier bit of the code. If you've got all four values and they're correct, we go, is the handle we're about to look at correct? If it is, should make sure it exists before we start getting it pointed to something because you will crash it. If it does exist, we get the pointer and we do these, we're picking these offsets from the structure. So this is the pointer to the first byte of the my character structure of this particular character on screen. This is the integer offset of that particular field. So we need to take this offset, multiply it by 4 and add it to the pointer and then read that value from memory. So we're doing the same thing to read each field. Once we've got them, just draw the highlighted circle. Yeah. Anyway, code will be up in the forums, of course. Take a look at it, get some different ideas about how you might approach stuff yourself. This is kind of morphed into, visualization idea pad, I guess you'd call it, as well as the how things work, how memory works kind of conversation. There's a lot in here to wrap your head around, but you could apply most of the things that we're doing here to a real program, particularly when you're building something, like an editing tool or where you need to modify something in your game as it's running. Give it a go, see how you go, and thanks for watching, and I'll see you next time.